Welcome to the sales training on the Infinera portfolio. I'm Praveen Mahajan and we will cover this session in about 30 minutes. We have 4 objectives in this session. The first is to take a look at the Infinera product and solutions heritage. Secondly, we will review technology leadership along 2 dimensions: capacity reach performance and cloud scale performance. The third objective of the session is to review solutions by network types along with the different products, covering long-haul subsea, metro, and data center interconnect. And the fourth objective is to bring all these products together in a portfolio view along with services. We do have a bonus section at the end, and that's covering the product naming hierarchy. The Infinera heritage has been about creating and seizing market inflections. In 2000, we were founded and we promised to do the impossible, which is to manufacture a large-scale photonic integrated circuit, or the PIC. And in 2004, we introduced the industry's first large-scale PIC. Now we chose to be a systems company and not a component company, and hence we used that PIC in our first platform, the DTN, and this was in 2005. And we found much success in the marketplace right after that. Our next milestone was in 2012 when we shipped the first platform based on a 500 gig PIC, which was the DTNX. In 2014, we entered an adjacent market with the introduction of the Cloud Express platform, and we effectively created a new market category that is referred to as a small form factor DCI. In 2015, we grew inorganically with the acquisition of Transmode, and we entered a third market, which is the metro. In 2017, we introduced products powered by the new ICE4 optical engine, and also we evolved the XTM platform to the XTM2. Now, earlier this year, in 2018, we introduced the ICE5 optical engine while completing a full portfolio refresh with the ICE4 based products and XTM2. Let's review the Infinera technology leadership on those 2 dimensions of capacity reach and cloud scale. Now, what does optical technology leadership mean for our customers? What really matters to them is to have a lower total cost of ownership while maximizing the fiber capacity reach. And last but not the least, to accelerate the time to the revenue, or the speed at which these transport services can be provisioned. Now, Infinera delivers this by increasing optical performance and having the best capacity reach in the industry. This is only possible because we have access to the technologies that enable such a performance, and that's the PIC, photonic integrated circuit, and from the electronic end, having advanced coherent technologies delivered using the DSP. Ultimately, we help drive the lowest cost and power per bit. Now we add to the capacity reach performance with a cloud scale performance through solutions like instant bandwidth, instant network, sliceable superchannels, and also open ICE and automation. And finally, it's not just about products and technologies, it's also about the experience of Infinera as a company for our customers. And we characterize that as the Infinera experience, helping customers win in their marketplace by using time as a weapon and by providing world-class quality products that are simple and easy to use. Now, when we look into the first dimension of technology leadership, which is capacity reach, we are highly differentiated in the marketplace through an integrated approach. Now, if we look at the discrete optics approach, where we have all these different components like lasers, detectors, amplifiers, multiplexers, attenuators, modulators, demodulators, waveguides, etc., we combine all of them with the use of a large-scale photonic integrated circuit. This approach is unique in the industry. Now we couple this photonic technology with the electronic technology, which we brand and call as the flex coherent processor, or the DSP, and the PIC plus the DSP form our ICE, or the infinite capacity engine. And these optical engines have been bringing Moore's law-like performance for optical. Now, optical performance can be viewed along three dimensions. The first being baud, where we increase the gigabits per wave. The second axis being about modulation and channel spacing, where we aim to increase the fiber capacity. The third axis is to increase the number of channels, and we do that by increasing the gigabits that can be delivered per unit. The ultimate goal is, of course, to reduce the dollars per gig and watts per gig. Now, the industry has been largely focused on the two axes of baud and modulation and channel spacing. The third axis, which is to deliver the highest gigabits per unit, that's by using the super channel technologies, that is unique to Infinera. And again, it's unique because we have access to the large-scale PIC technology. This helps in the CapEx reduction, OpEx reduction, and also increases the reliability. To give a perspective of the increase in reliability, a discrete component like an SFP Plus has a failure in time metric of around 225. The PIC has a failure in time metric of around 0.6. That's a 350 times better reliability than the discrete component. Now, Infinera, of course, has deep expertise in photonics, and this began all the way from the first generation in 2005 with the 10 by 10 gig PIC. In 2012, we introduced the 5 by 100 gig PIC, and we also added the ASIC at that time, because that's the time when coherent was introduced to the marketplace. Now notice we did not use the ICE, or the infinite capacity engine nomenclature, at that point in time, because we introduced that in 2016 from the fourth generation. So the ICE family begins from the fourth generation. ICE 4, ICE 5, ICE 6, etc. And we aim to deliver 24 months between these different generations. ICE 4 is targeted for 200 gig per wave and with 33 gig baud. In fact, we are already shipping that. ICE 5 is up to 600 gig per wave with target spec up to 66 gigabaud, and ICE 6 800 gigs per wave, 100 gig baud target. And we are also in the planning for the next generation ICE engine with a target of 1.2 terabits per wave and 133 gig baud. Now, of course, these are headline specs for the best performance, and these types of performance are typical for long-haul subsea type of an application. For an access type of an application, we also have plans for the 100 gig per wave coherent PIC. Now, expanding on this capacity reach performance, when we look into the operational efficiency and the technology which we introduced to the marketplace, the super channels, this effectively provides bandwidth as a single unit of capacity that can be provisioned in one operational cycle. What is a super channel? It is a group of multiple coherent carriers that can be implemented in a single device. Next, we introduced Nyquist subcarriers to the marketplace, and this again was an industry first. Nyquist subcarriers help lower the baud rate. Nyquist subcarriers, effectively what they do is we split a super channel carrier into multiple such subcarriers, effectively allowing us a gain of around 0.5 to 0.8 dB. By doing so, we increase the tolerance to non-linearities like cross-phase modulation. The second technique which we introduced to the marketplace, and again being an industry first, was a soft-defined forward error correction, or SDFEC, gain sharing. Now, this is only possible because we have a two-channel DSP. Effectively, what we do in this technique is we equalize the performance across two channels. The one with the higher performance, which is a blue channel, can impart its strength to the lower channel, which is yellow here. And by doing so, effectively, we increase the gain in the orders of around 0.5 dB. This technique helps mitigate nonlinearity, and it also helps enable us to use a higher order modulation. Now we couple these techniques with others in the ACT, or the Advanced Coherent Toolkit, techniques like tight channel spacing, increased tolerance to lightning, and nonlinear compensation. All of these techniques help deliver the best capacity reach or spectral efficiency in the industry. All of these techniques are Infinera only, and we are shipping them today across the ICE4 platform. Turning over to the other dimension of technology leadership, which is to do with cloud scale. Now, a typical way of provisioning bandwidth is to have a truck roll whenever there is a need for the next increment or the next step of 100 gig to be provisioned at a location. For Infinera, this is a pool of intelligent bandwidth, and all of this is pre-activated, and it just needs a single mouse click. It's an on-demand instantiation of this pool of bandwidth in 100 gig increments. It's highly granular. It's enabled per device through a line card or an appliance, and it is truly a software-defined capacity activation in minutes. The benefit of this technique is to pay for bandwidth in proportion to the incoming revenue from the end customer. And we've taken this concept further by having a license pool where these licenses can be grouped together in a pool and applied to the network as needed. These licenses can be transferable too between different sites, and we also enable the use of time on this bandwidth, providing a truly flexible pool of bandwidth for our customers. This is unique in the industry, and we have over 70 customers today who are enjoying the benefits of instant bandwidth. And we are taking this further, helping customers use time as a weapon by going to the next stage of instant bandwidth, which is instant network. Now, if you see on this axis, capacity planning used to take months. We shrunk that to minutes using instant bandwidth. And with instant network, where we now have pre-deployed capacity and techniques where we can automate some of this deployment through automated capacity engineering, now that we are talking about having this instant ordering and automation of bandwidth delivery in literally within seconds. Where is this marching towards? Cognitive networking, where the system learns from the characteristics of the traffic flows and then can determine what are the new routes, what are the places where we need new bandwidth, what are the failure scenarios, and maybe we should provision some bandwidth for that link proactively. And this is really getting to autonomous control of the network. Are we there yet? No, but ultimately these stepping stones which we have built in our systems, the photonic integrated circuit and the DSP, the instant bandwidth layer on top of that going towards or enhanced with instant network, those are foundational technologies marching towards the ultimate vision of an autonomous network. Now, another dimension of cloud scale is open, and we help advance customer flexibility through the deployment of open systems. Now, this is on through the use of having Infinera deployed on other third-party systems, like the ones which you see on the left-hand, on the right-hand side here, with the most open engine, the Infinera ICE platforms, which has been validated across several vendors, several third-party line systems on fixed grid as well as flexible grid. And on the other hand, on the left-hand side, we see the Infinera flexible grid line system, or the FlexILS, which enables the use of Infinera systems, of course, and also third-party terminals. And finally, we have an open philosophy in product engineering and design on these three different dimensions of having open interfaces, using open source where possible, and using open information models like Yang in our software code. We are also helping lead some of the open standards in the industry through our participation and leadership on various bodies like the Telecom Infrastructure Project, or TIP, that's being pioneered by Facebook, Cable Labs, Open ROADM, and ONF. Now, here are some proof points of the Infinera technology leadership. On the optical front, we have delivered the industry's highest spectral efficiency on ultra-long-haul networks with a shipping product, 8 QAM, 4.5 bits per second per hertz on C-band for over a 10,000 kilometer link. Now, we vastly exceeded the target which the customer had, 12 terabits on their link by showcasing 18.2 terabits, and this was last year. We also surpassed the competitive spec on that type of link. We also delivered or showcased this on an ICB network, having demonstrated 27.6 terabits for a metro DCI type of an application last year. And very recently, we showed the first use of 16 QAM on transatlantic fiber, achieving 4.4 bits per second per hertz. Just this past few months. With the next-gen optical technologies, those which we have in I6, I7, etc., we showcased 100 gig baud results and also 1024 QAM along with constellation shaping. These we had demonstrated last year. Both were industry firsts at the ECOC. They were presented at ECOC 2017. From the packet optical front, we have over 100 gay ports deployed on the XTM series. It is number one in Europe in the Metro Edge ports, and it serves demanding applications like video distribution, cable TV, mobile backhaul. It also offers industry's only 400 gig plus switch on a blade architecture with a leading performance in the packet transport of low latency and superior sync. Let's now turn to solutions by network types along with the products. Now, if you look at the customer context, the networks are being reimagined today. Traditionally, we've had telecom providers build networks through the cable infrastructure or a mobile infrastructure or delivering a broadband type of an infrastructure. And this type of a network was built with these principles in mind for a mesh type of a traffic flow, having mice flows or 1:n type of a connectivity requirement. Now that requirement necessitates a more integrated platform approach to serve multiple services, and also needs to be highly secure because it connects ultimately to the end user. It has to be sliceable in nature, more granular. On the other hand, on the left-hand side, we see the emergence of a web scale type of a requirement, which is built on a different philosophy, on a scale-out approach, DevOps type of a development and operational melding together. And the traffic patterns are quite different. Linear type of traffic flows, elephant flows, characterized as elephant flows, huge flows, 1:1 type of an architecture or a connectivity link. And this necessitates a network to be highly scalable, also disaggregated, and also open. Now, this is really not an either-or approach for Infinera. We approach this as a cloud scale solution, and it marries the best of both the worlds with an SDN control and orchestration layer at the top through the use of APIs. Now, these web scale dynamics and telecom dynamics are having a huge impact on the network architecture across access, across metro aggregation, and across long haul. On the access, bandwidth keeps growing, and DWDM keeps moving to the edge through the emergence of 5G on the mobile side and DAA remote PHY on the cable side. For the metro and aggregation, data centers today are moving to a core type of an architecture. There are new applications and new IoT connected devices that demand lower latency between the access and the data center. And finally, in the backbone or in the long haul, bandwidth obviously continues to grow, being fueled by these access architectures. But we are seeing an increasing use of DCI and subsea links for point-to-point connections. OT and switching still remains important. Now, underlying all these different areas of the network is a need to have a completely programmable infrastructure, and that's delivered through APIs, SDN control, and automating various aspects of the operations. Let's turn our focus towards the long haul and subsea, and how Infinera is addressing long haul and subsea. Bandwidth continues to grow. OT and switching is still important. We deliver this through the portfolio of DTNX XTC and the Flex ILS. Some of the features of this portfolio include a seamless upgrade from Gen 3 to IS4, enabling higher modulation of 16 QAM, high density 12 terabit switching, muxponder capabilities. We bring the economics of the super channel at 1.2 terabits to this portfolio, and also the flexibility of sliceable photonics. We are also adding resiliency in optical through the use of new optical protection methods. And finally, Flex ILS brings flexible grid to this entire infrastructure. Now you will notice here that we have various form factors of the XTC 10, 4, 2, 2E, and 2. So we have a range of different platforms from 45 RU all the way to 12 RU in the XTC. On the Flex ILS front, there are two chassis here. You see a 7 RU and a 4 RU. And the line system components like ROADMs, the 4-degree, 9-degree, and 20 degrees, the MUX components, the amplifiers, and the switches, WSS, all of those are part of the Flex ILS portfolio. Now, when we look into the increasing links for DCI and subsea and the point-to-point type of systems, these complement or supplement the switching systems at the top. Here we have right-sized form factors, the 1.2 terabit and the 2.4 terabit mesh ponder. Now, the mesh ponder is a transponder, muxponder with sliceable photonics. Sliceable photonics is where we slice the superchannels into multiple different directions, enabling a mesh type of an architecture in a network, and that's the reason we call this as a mesh ponder. We continue to use higher modulation like 16 QAM, and we bring superchannel economics to this portfolio as well. It is enabled for multi-services aggregation as well as 10 gigs. And here we have the XT500, the XT and XTS 3300, and the XT and XTS 3600. The 3600 being 4 RU, the 3300 being 1 RU, and the XT500, which is Gen 3 based, being 2 RU. Let's now turn our attention to the metro and the access and how Infinera addresses this today. As bandwidth moves to the towers, businesses, and homes, the XTM portfolio serves these type of traffic needs by delivering low power systems, higher modulation through the use of 16 QAM, high density switching, higher density packet optical aggregation, and also mobile and cable optimized. There are a number of services that are supported across the XTM portfolio. The XTM has a 300 millimeter deep type of a form factor, and there are three types of chassis here that you can see: an 11 RU that supports 4 terabits, a 3 RU, and also a 1 RU. We also have the HDEA 1600, and this is new. It's 1 RU, 80 ports of 10 gigabit targeted towards a DAA or a 5G type of an access infrastructure. Now we have around 35,000 of these XTM units already deployed across our customer base. We also have application-specific offerings, which you see below: a hardened pizza box EMXP, which is for remote aggregation, hardened appliances for mobile SIPRI and eSIPRI, and all of these are designed for open, low latency, and low power. The portfolio also includes the passive WDM filters, or the XTG, and these are hardened 10 gig products. We have 1 RU and 4 RU form factors for a manhole or a wall mount type of deployment. Next, we see how Infinera addresses DCI and automation. Now, as data centers move to metro, The DCI traffic is climbing, and the Cloud Express, which we introduced in 2014, created a new market category. And the CX10, CX40, CX100, CX500F, that's the Gen 3 based Cloud Express family. This provides 500 gig in 2 RUs. And the Cloud Express 2, which is CX1200, provides 1 RU and 1.2 terabits, goes up to 130 kilometers or so. Also includes a layer 1, layer 2 encryption. And we supplement that with the DTNX XT3300, which is targeted for a long-haul type of an application. Now, the characteristics of this portfolio, the DCI portfolio, are higher modulation, flexible baud rate, rapid provisioning, strong security, low latency, and also open interoperability. Now, finally, on the automation front, as customers push all the vendors in the industry to expose their network APIs and also introduce more flexible ways of managing the network and provide more control, we've been keeping pace with these customer requirements through instant bandwidth, which we did see before, where we can literally provision bandwidth in minutes and providing the utmost simplicity in operations. We also have advanced telemetry and interfaces like the gRPC, standards-driven models like the MEF LSO type of a model on our software products. And we make it flexible for the customers to deploy the control application and or the management application. Now, the products which we have for this include the IMS portfolio, and that includes the DNA network management system, the GNM or the graphical network management, and a planning tool which we call as the NPS. For control, we have the Exceed platform or the Exceed software suite, and that includes a controller, a path computation element of the PCE, and various applications which we have in the plan, such as DPW, dynamic bandwidth, IVN, which is a type of an optical VPN, and also planning applications like ARE, ACE, and ASP. Now, if we look at all these different products and we were to have a consolidated view on a single slide, this would be it, where we have the metro products, the long-haul products, and subsea as well as DC interconnect, and all these different products and how they fit in these different type of applications. Now, notice at the top, we have a common control and management layer through Infinera Exceed and DNA, and also a common line system at the bottom through the flexible grid or the Flex ILS portfolio. Now, we complement our product with services, and here we span the entire gamut of a customer's lifecycle, beginning with deploy, and then going to operate, and also going to optimize. Now, within deploy, we offer installation services, and that include turnkey services or simple rack and commissioning as well, or only commissioning. We do pre-staging, software install and configuration. We validate and test as well. Specifically for open and for open ICE, we have alight and validate, because that needs a lot of validation as we deploy our systems or alien infrastructure. In operate, we have spares management, field maintenance, the first line maintenance, as well as AMC or add move changes, NOC services, and network health check as well. In optimize, consultative and managed services to do audit optimization, as well as build, operate, transfer. Some customers have adopted that as well in managed services. Through all these different stages of the customer lifecycle, as I did mention, professional services, warranty and subscription, that includes stack, and finally training as well, and that includes e-learning type of courses for our partners and the engineers on the field. Now, when we bring all these products in a network-wide view, and this is for the current generation of products which we are shipping, and this blue layer is about using the ICE technology across different products. The transponder products, which you see on the left-hand side, which are optimized for linear flows. And the mesh bonder products, which you see in the middle and on the left-hand side, along with the switching type of products, which are optimized for a mesh type of a traffic pattern. And here we use sliceable superchannels as well to redirect the superchannels in different directions. Now this blue layer, which is enabled through the use of ICE, has a foundation of an open flexible grid system, which we see here in gray, through the use of Flex ILS. And here we show the linear flows of how they are connected using Flex ILS, and then we add to that with the same line system supporting the mesh type of traffic flow as well. Now, all the products or the blue layer are fully compatible with third-party line systems as well. We also add to this with a muxponder type of a platform using the XTC22E for a metro type of an infrastructure, and a packet optical going all the way to layer 2 2.5 with an XTM2 type of an offering for a metro application. And finally, all of this is provisioned using DNA, Exceed, and instant bandwidth, delivering software-defined capacity, which is a new type of user experience. It features low-touch pre-activated capacity for pay-as-you-grow, helping deliver a true cloud-scale infrastructure that has a combination of disaggregated and integrated solutions with a unified SDN control. In fact, we quantified this type of an approach for a US topology, and we found that it has a 56% lower TCO as compared to the competitive architecture, the competitive solution offering in the industry. Now, I did mention a bonus section at the end, and this is the product hierarchy at a glance. We do have a method in the madness of how our products are named, categorized. This slide gives you a view of how we categorize all the products across these different offerings which we have. So it begins at the top with the family, and each family has a series. Each series has a model, and ultimately each model has a pawn. A pawn is something that is orderable by the end customer. Now, the green boxes are popular references, so you will hear a lot of people talk about DTNX, XT, XT3300, XT3600, XTM, XTG, FlexILS, Cloud Express. These are the common names that we typically use for ourselves across different presentations, across different customer meetings. There are some boxes which are in gray, and those are planned or future offerings. Now, this product naming document and many other sales presentations are hosted on our internal portal, which we call as Smarter. Please check them out, as well as other training modules that dive deeper into each product family. And there are many different modules which you should be having a link to that soon. Thanks for watching, and have a great day.